Greetings and welcome back. This is the last video of the Build SHA-1 Hash from Scratch playlist. And good job if you make it to the end. I hope you enjoy it and I want you to bear with me until the end because this is going to be the hardest video of the series. And let's get into the compression function. The idea of compression function get inspired by these two legendary cryptographer. It's Merkle and Damgard. And Merkle, as you might know, he's the invented the Merkle root as well. But that's another story to tell. And the Merkle Damgard construction is the foundation of the compression function as we know it today. It's also inspired to for the SHA-1 and SHA-2 hash function that's very popular in the last 20 years. Okay, so how it works, the compression function. Last time we talked about we have the ingredients that we cut into 512 bits block and then we put it into the oven. Right now we're going to dig into that oven, what it does, and then we output the A, B, C, D, E of the five groups and that we concat together. Okay, so once we get the 512 bit blocks, we're going to cut it into 16 words. So we cut it, and then we get the 16 words, which is like word 0 to word 15. And as you can see, we just like direct cut it. And this is a very simple process. Now we get the 16 group of it. And now we want it to expand to 80 words. We just don't want 16 groups words. We want 18 words. What we're gonna do? We're going to expand it with some equation, which is these equations. You can see the pattern here, but we're going to do some left rotation and exclude all the things that we learned in bitwise operations. We're going to use it now. Okay, let's see the example of the word 16. We doing left rotation between the exclude all of the word 13, 8, 2, and 0. And now if I put the numbers in, this is the numbers, and then we do the exclude all, we're going to get this one, and we do one left rotation, and this is the word 16 that we get. And we just keep repeat the pattern of the 17, 18 until 79. This equations is going to repeat itself. You can see the pattern. You just keep incremental the numbers, and then you get all of those 80 words that we need. Okay, now we get 80 words. Let's put these ingredients into the fridge, and we will come back to it later. But now I want you to focus to another thing, which is the A, B, C, D, E of the output that we will have it. Okay, we need to start with the initial value, also known as the IV initial value. This is the fixed value, so it's already stated in the standardization that we need to use this fixed value of the A, B, C, D, E. Everyone in SHA-1 hash function, we will start this with these numbers. Okay. Okay, and then we're going to do a manipulation of the data for 80 rounds. It's going to be long, long rounds. I show you the example of what it looks like. And okay, let's bring the 80 words, get out of the fridge, and then now we're gonna cook it. So for the 80 rounds, we have 80 words, right? And for the first round, we use the first word and then A, B, C, D, and then we put it together. We do some manipulation, mix it together, and then we get the new A, B, C, D, E. And then we put the second words, and then we do second round, and then we repeat it for the 80 rounds. And that's until the end, we get the A, B, C, D, E out of it. Okay, first round. Let's see the example. This is the equations for the first round. And we do some left rotation 5, and then we have some and or not and. That's all we learned in the bitwise operations. And now we got some the first word that we already computed, that we get out, take it out from the fridge, and then some constant here in the hexadecimal, and then we just combine it together. Boom, and then we get this temporary value. T stand for temporary value. And once we get the temporary value out of the first round, we're going to do something we call chaining updates, which is we're going to assign the value of D to E, C to D, B to C, A to B, and then the temporary value that we get from the last slide, the last slide, and then we assign to A. So you can see that all the A, B, C, D, E, right now, the value is changed. You can see that after we cook for the first round, we assign to A move to B, B move to C, D move to E, and then now all A, B, C, D, E, it's changed all the values. and then we do it again for the second round. We're going to have the updated A, B, C, D, E, and then the second word. And then we do it again, the same equation. We cook it again. But because there's new values that we put it in, so they always produce the different output. And we're going to update the A, B, C, D, E again. And we keep repeating it for the 80 rounds. Okay, this is like the round one, the second round, and as you can see that we use different words. This is going to be the second word, and then we do the chaining updates again. And let's say we do all the done. Let's say we do all the 80 rounds. After 80 rounds, you get some A, B, C, D, E, and that values you just concatenate it together, and then you get the digest. You get the hash that you want, and this is the output process already. Mhm. Yeah, that's it. Congrats, you get the hatch. And that's pretty much how the hatch SHA-1 works. Okay, I need to confess you something. I made three white lines. The first one is that we must add the modular to power of 32 in every calculation. I removed that. I ignored it for the sake of the simplicity, but in reality, we need to do a modular arithmetic in every calculation we did. Second line that we did is that when you assign the values to C from B, you need to do a left rotation of 30. And yeah, that's it. And the third line is the biggest line I made, which is we need to use different function and constant for each 20 rounds. We do 80 rounds, right? I only show you the first round and second round, but this is the function that I show you. But for the 20 to 40, 40 to 60, 60 to 80, it requires different functions and different constant that we put it in. You can see all the details here. I don't want to spend most of my time to dig into what is the equation is like, but you get all the ingredients you need, which is the bitwise operation. It's only need and or exclude or not and modular arithmetic that you already understand it. So I'm sure you get all the things that require to understand this 80 rounds function. And it's always doing the same training update, which is you update all the A, B, C, D, E, and yeah, that's it. And then you get the new A, B, C, D, E, and then you concatenate it at the end. If you want to understand in coding, if you're a programmer, you can scan the QR code and then see the pseudo code for SHA-1. Pseudo code is like it doesn't any programming language. It's just like pseudo code. You can understand it easily, and you can check it out here. All right, and that's the overview of the three steps of the hash function. We prepare the input and we put it into the compression function, and then we get the output. And I hope you learned something new for the build SHA-1 hash from scratch. And if you want me to do some simplify for any concept in cryptography, just comment it below. Let me know. And thanks for watching. Please subscribe and click like. Thank you. Goodbye. See you next time.